Welcome back. Now, if you look at it here, this is where we stopped, all right, in the last video, okay? So we have the etcd.yaml, we have the kube API server.yaml, we have the kube control manager, all right, the YAML, and then we have the kube, all right, scheduler, the YAML, right? Now you can actually open up each of these files and basically just, explore what you have there. So I can do sudo, all right, cat, and then here I can copy this path, all right, paste it here, and then I can say /etcd, for example, right? I can basically see what is available there. Now, all of these files were basically generated by the kubeadm init command, all right? And then, of course, the kubelet will actually take this file and use that to create, all right, the etcd component. And then the same thing applies to the kube API server. The kubelet will take that, use that to create the kube API server component, and of course, the controller manager component and the kube scheduler, all right, components, right? Now, before we clear the screen, we already have an idea, all right, that our configuration file, right, which is the admin.conf, is actually in this location. So how do you connect to, all right, your Kubernetes cluster? I mean, we've initialized the cluster is ready and all of that. So let's take a look at what we can do, sudo kubectl get node, right? So here I will say I'll say sudo kubectl. Now, the reason I'm using sudo is because I cannot use the kubectl command directly because I've not configured, all right, my kubeconfig file, right? Because I mean, if I do ls, for example, if I do ls and then I use the tilde sign here, right, I can see that I don't have anything here, all right, at the moment, right? Or if I do ls-a, for example, and this sign here, I mean, I don't have any .kubeconfig folder right here in this location. I don't have it there. So basically, if I just say kubectl, all right, for example, it's not going to give me anything. So for example, if I say kubectl get node, for example, right, it's going to give me this error, right? Basically, couldn't get current API server group list. I mean, I don't have any kubeconfig, all right, in my home directory. Okay, so let's clear the screen here. So what we can do is to say sudo, all right, kubectl. All right, so I think that's not spelled correctly. Kubectl. All right, so we can say get node. All right, so watch this. Get node, and then we can say -kube config. So basically, we're saying that the kube config is actually in this location. So basically, look for the kube configuration file in these, all right, locations. So etc kubernetes admin, all right, .conf. So that is where the location is, right? So basically pointing our Kubernetes, all right, kubectl command to basically look for the kubeconfig file in this location, all right, to basically give us, all right, the output for this. Now, one thing you will see here is that it says control plane not ready, all right? Control plane is not ready. Now, the reason why the control plane is not ready is basically because, I mean, you don't have, all right, the communication connected just yet, right? The networking has not been configured, all right, just yet. And that is why it says the control plane is not ready, right? So that is why you have that particular error right there, because the connection, all right, or the communication between the pod, right, has not been activated. So that is what you call the pod networking. All right, so the pod networking has not been done. So that is why you have the control plane status as what? As not yet ready. Now, what can we do, all right, to make it ready? Now, before we make that configuration or the control plane ready, let's basically, do something about this particular path, right? I mean, we can copy this, all right, configuration here into the kube, all right, config file. So we can actually just do that right away. So how do we go about that? Now, what do? We basically do something like this. So we say mkdir, all right, -p, right? And then we basically create, all right, a kubeconfig folder in our home directory. So that's the first thing that we have, all right, to do, right? So that's the first thing we have to do. Now, of course, it gave us all of this configuration by when we created the cluster, but of course, for learning purposes, let's try to do these, all right, by our own self. Now, the next thing is to copy that configuration. So you say cd, all right, sudo copy, all right, sudo scp-i, all right, and then you say /etc, all right, Kubernetes. So we're copying something from here, all right, and what we're copying is this admin.conf, and we are copying that to this particular location, all right, kube, and then we put that into what you call the config. Right, I'm sure for some of us who have launched a Kubernetes cluster before, are using EKS and all the other tools. All right, you already know what the kubeconfig, all right, is about, right? So we are copying whatever it is that we have here, all right, into this kubeconfig. Okay, so that is exactly what we're doing, and then we press enter to do that. Now, the next thing we need to do is that, our Ubuntu user right here should have access to the kubeconfig file. So we need to do some kind of change of ownership because, the copy, all right, actually happened with sudo. That means the root user is what we use to actually execute that. So, but then we need to give our Ubuntu user, all right, access to this kubeconfig file so that naturally we can just do something like this, kubectl get node, all right, without having any issue and without putting sudo before executing, all right, the command. Okay, so here we can say sudo chown, all right, and then we're going to use what you call a command substitution. So in our own case, we can use the $ and then put everything in the bracket like this. But of course, we can also use the command substitution, all right, the backtick rather. All right, instead of using the $, we can use the backtick. So we can do something like this. And then here we can say ID, all right, -u, basically. Okay, and then we can say the backtick. So basically, we're substituting, all right, the user ID. Okay, that's what we're doing actually. So we're substituting the user ID, and then we can say here colon, all right, another backtick like this, and then we can say ID -g. So basically, the username and the group. All right, that is basically what we're doing. So the ID is Ubuntu, all right, the ID of the user is Ubuntu, and then the group is also, all right, Ubuntu. So we can do something like this and then do something like this, right? And then that would be .kube, all right, config, okay? And then we press enter. All right, now it says that is not found. Now, what is the issue with that, right? So that should be something like this, I guess. So -d like this, all right, separate that in this manner. All right, and then you press your enter and that accepts it. So the ID-u should be separate. Now you can also run the same thing in this way. So you can say chown like this and then put your $ here, open up a bracket and then say ID-u, close the bracket. All right, and then put something like this here. All right, and then you can put something like this again, open up the bracket here and then say ID-g. All right, close the bracket and then just say this kube config, all right, like this. So whether you use this method, all right, or you use this method, it is actually, all right, the same thing. So basically it is command substitution. So in Linux, you can do command substitution in two ways, either using the backtick or using the $, all right, symbol. So those are the two ways you can do, all right, the command substitution. So to find out if the backtick that we used worked, we can basically just say kubectl now, all right, get node. Okay, that should not give us any error, all right, again. So of course we can still see here that it says the control plane is not, all right, ready. Okay, the control plane is not ready, and of course we can say kubectl, all right, kubectl, all right, get ns. So basically we want to look at the namespaces that we have. So the namespaces that we have is this. So we can see that we have the kube node list, we have the kube public, and we also have the kube, all right, system. Okay, so those are the namespaces that we have, right? And most of the things that we created will actually be created inside of this kube system. So we can copy this and say kubectl get, all right, we can say get ports, all right, kubectl get port, all right, so the namespace is basically kube system. So we want to look at the port, all right, inside of the kube system, okay? Kubectl, kubectl get, right? So get port, right? And then you press enter. So here we can see all of these ones. So you kube API server, we can see the control plane manager, we can see the kube proxy, we can see the kube scheduler. All right, now all of these guys are running. You can also see the etcd control plane, right? All of these guys are actually running. But now you can see that we have this issue here. The core DNS is what? Is pending. So the core DNS is pending because it is waiting for us to configure what you call the pod networking, right? Because without the networking, there is no way that each of these components can actually communicate with themselves or the worker nodes, all right, as well. So the next thing we need to do now is to configure, all right, the networking, right, which is the container run, all right, the container network, all right, interface. That is the next thing that we need to configure. Now, in order for us to configure the container network interface, we're going to be using, all right, a container network interface that is called the Selenium, or Selenium, all right, that is what we're going to be using. Now, there are different container network interfaces that you can actually use. Next thing we need to do is to configure the CNI, all right, container network interface. So let's go ahead and let's see how we can install, all right, Selenium on our system actually. Now, the easiest way to do that is just basically to do sudo, all right, install, all right, Selenium. Okay, I hope I got that right. That's the more like the easiest way, all right, to basically just install this. Okay, but let's take a look at how to do this better. So now here, let's look at the Selenium, all right, installation page. So this is Selenium quick installation, all right, and we want to scroll all the way down. All right, so let's see, install the Cilium CLI. Okay, so this is the first thing that we need to run, right? We need to copy all of these and, execute all of that. I mean, that's the first thing that we need to do, because just like your kubeadm, your kubelet, your kubectl were not available, all right, in your app repository, that you had to add the kubeadm and kubelet and the kubectl repository to the apt, all right, lists. Okay, the same thing also happens with Selenium. So we have to copy all of this. So I'm just going to say copy all, and I'm going to drop it here. Right now, pay attention. I'm doing everything I'm doing here on the control plane. Okay, on the control plane. Okay, so pay attention, do that. All right, so now that is done. The next thing now you can do is basically to just go ahead and say Selenium install, right? And that will install, all right, that for you. Of course, you can specify the version that you want to install. Perhaps if you want to install any version that is, lower than that. Another thing that you can also do with Selenium is that, all right, now the Selenium is more like the network gateway, or the gateway by which your pod can communicate with one another, and by which your control plane and your worker node, all right, can also communicate, right? Now, your node already has its own IP address, right? So the IP address of our node is basically the IP address that the VPC, all right, was configured on the VPC, and that is 172.31.0016. Now, when you're also configuring Selenium, which is, of course, will have to do the networking for you within your Kubernetes cluster, and that means it is going to have to create a network, right? More like a flat network, all right, for your control plane and your worker node, that every of the ports that you create, all right, will have to, get their own network, right? So that means one thing you must pay attention to is that your node, all right, the IP address of your node, which is the VPC's IP address, must not overlap with that of the Selenium, all right, IP. Okay, you want to check that, and you can also change that, all right, as well. Okay, it is something that can actually, all right, be changed. Okay, so we want to make sure that the IP address does not overlap. Now, by default, if you go here to the M reference for Selenium, right, you can see that by default, the IP address here is actually 10.0.0.0/8. I mean, that alone does not overlap, all right, with the IP address, all right, of the system. So we can actually just use what we have here by default, okay? I mean, without any kind of issue, really. All right, so here we can go ahead and just say Selenium install. Right, we can copy that, all right, and go back here and just say Selenium, all right, install. Even if you don't specify the version, it will still go ahead and install the latest version, all right, for us. So let's go ahead and run this command, and let's see what we have with that, okay? So let's execute that. And then here it says, using Selenium version 1.16.0, and it says auto-detected cluster Kubernetes, auto-detected kubeproxy has been installed. I mean, that was more like a quick work, okay? But we can come back here again and try to see the status, okay? So here you can copy this also and say status, all right? Or you can actually just copy this one and say Selenium status and then wait, right? To just see what is going on behind the scene. So we can copy all and paste that right here. Oops, I mean, that was not what we intended. So let's clear out all of that, right? So let's clear out everything that we have here up to the Selenium status, command actually, okay? So let's copy all of that. That was not what we intended. So I mean, it just copied everything for us. So copy, delete all of that. And then let's just leave that up to this point. So we check that and it says command not found. Wow, interesting. So why is that? Because I mean, there's this one here and there's this other one here. So that's where the error comes from. So we can actually just, copy, delete that also, and there's remove that and then press that. So Selenium status wait will basically just wait. And interestingly here, we can see that Selenium says okay, operator says okay, envoy daemon set or daemon set says okay. And here we can see that it says ready, ready, and everything is running. All right, 2 of 2 managed Selenium pods is running. All right, and everything seems to be, all right, configured already. Right? So the cluster networking has been activated, right? So now if I do kubectl get nodes, okay? Now let's see what we have. I mean, it says now that the control plane is ready, right? So now if I come here and I say kubectl, all right, get pod -n, and I say I'm looking for the pod in kube-system, all right, now I can see that my core DNS is what? Running. I mean, that is really interesting to know, right? And here we can see that it has installed the Selenium pods, right, as well. Now, the Selenium pod is actually what you call a daemon set. Now, what exactly, all right, is a daemon set? Now, a daemon set basically, all right, it is used when you want to ensure that, for example, now I have 2 nodes, right? The moment I join my nodes to my control plane, automatically the daemon set will run automatically on that node, which means I don't have to go to each of the nodes to basically configure networking. All I need to do is to join the worker nodes to the control plane, and automatically Selenium or right daemon set will be installed on that node and then will configure the networking for me automatically. Right, that is basically what a daemon set is, right? It basically just does all the installation for you automatically. So as you add node to your control plane, the daemon set executes on that node, and then it configures the networking for you automatically without you having to do all right much. Okay, so now Selenium is working. We can see that here our control plane now is ready. All right, the core DNS is working, so the port-to-port networking has been configured as we intend, and everything seems to just be going on very, very well. Now, the next thing we need to do here, because I mean, Selenium also has some security group or what you can call firewall requirement, which means Selenium also requires that some port be opened up in your security group that will allow your worker nodes to join the control plane, to communicate with the control plane basically, because right now the worker node are still just on their own, right? They are not a member of the master node or a member of the control plane. They've not joined, the control plane just yet, right? So we need to configure some firewalls that would allow that join to be possible, or that will make that join, possible, and all of that. So what do we do? How do we go about that, right? So here we can also go here to the system requirement. I mean, all of these links will be put in that, in the Git repository. All right, you can go there and then grab the links and make use of that also while you try this out on your own as well. So here for the master node, we have these port numbers that should be opened up, all right, for us automatically, okay? And then for the worker nodes, we have these numbers that should also, all right, be opened up. So we need to start with the master node. I mean, we have to do this before we start joining the worker nodes, all right, to the control plane. Is that okay? So first of all, let's start with the control plane, okay? Let's start with what? With the control, all right, plane. So here we have these 2379, 2380. All right, we have that, and that should also be opened up, all right, for us. Now here, if I look at it very well, I can see that that is already opened up. I mean, if I go to my security group, all right, so let me open up the security group. So if I open up the control plane, I should see that that is already opened up. I mean, that 23 something that we can see here, all right, right here. it is actually for the etcd, right? And for here, from here, we can see that we already have that, all right, configured already. Okay, so I don't think we need to do anything with that, all right, again. So we have that opened up here already, and that is the etcd, all right, SAL. Okay, so the next thing we need to check out is this one. So, and that one is 8472 UDP, right? 8472, all right, UDP. So we need to check that and open that up, all right, as well. And this one says, all right, the source and destination should be the control plane, right? And then it says it should be self. So which means, I mean, I should be able to touch, just talk to my own self, right? So that is what it means. So we can go ahead and configure that. So let's grab the number. The protocol is UDP and the port is 8472. All right. So let's go here, hard rule, and then of course it says UDP, so don't forget that. So it is custom UDP, right? So custom UDP, okay? So don't let us forget that. So custom UDP, and then you put the port number here, and it says, I mean, I should be able to talk to myself, right? That's what it says here, right? Self. So come back here, and then here specify the security group of the control plane itself, right? So specify that. And the next one is basically has to do with the worker node. So we're going to do that later for the worker node. So the next one here is the 4240. So copy that. Okay. And then come back here, open up. So that is that is TCP, right? So paste that. And that is also self, right? So self. So, I mean, that is very self-explanatory. So control plane also, and then had another rule. So the next one we're adding here, we already had the ICMP, right? So we already did that. So we already did ICMP. And for the egress, now we're not configuring egress because, I mean, we're using security group. And on AWS, your security group basically is a stateful firewall. So whatever it is that you allow in automatically is allowed out. So we're not configuring any kind of egress. Okay, so let's go to the worker node and let's see what we need to configure. I mean, we can actually use what we have here, but I mean, I just want us to look at the session for worker node, all right, separately. So we can come here, and after all of these is done, we can basically, 8472420. And let me see, I think that's the two that we had. I mean, we already had these, so we have this two. So I can just delete this one and then save Narush. So control plane done, and then let's move over to the worker node. So let's open up the worker nodes now, all right, and basically just do the same thing. So I'm going to edit the inbound. So copy that, okay, and then come here, and come here, 8472, so that is worker node, and it says self, right, and that is also ingress, okay, and this one also for the master node, it says self, and that is also what? Ingress, right? So let's take a look at what we have here. So copy that for worker node. So it's self. So come here to the modification space, add the rule. All right. And that is UDP, if I'm not mistaken. Paste that. All right. And then the worker node, all right, security group. Okay. Because I mean, that says self, right? It says self right there. So let's see what will happen. Okay. So it says self, and let's see. All right. So the next one here will be what? 4240. So that also says self, and that is TCP. So copy that, and then you can open up another one, which we already did. So, and then that is also going to be self. All right. So you can configure that as well. Right. Now that is basically, all right, the configuration, all right, for the worker node, all right, as well. So that is saying self. Okay, but then another thing that I think we can also do, all right, is to configure, all right, something. I mean, we want the worker node to be able to communicate with the control plane. We can also do some kind of, communication between, the two systems now, because we're using the security group. I mean, the control plane security group is not the same as the worker node, all right, security group. So now that we have configured all of these ones to communicate, amongst themselves, we can actually also do the same thing for this, all right, the worker node to communicate with the control plane. So these self ones, they are good here, But the one thing we need to add again is to come here and say UDP. So we're going to copy this number, all right, and put it here. And then we're going to come here and say now the control plane, which means, you should be able to communicate either way, right? So control plane, worker node, control plane. Okay, so I'm going to copy this number again, add the rules, of course, and that one is TCP, right? So put that here, and that'll be from the control plane, right? So there should be that kind of two-way kind of communication, right? It's not a one-way communication, right? So your worker node, your control plane, they should be able to communicate either way. Okay. So we're gonna do the same thing for for the control plane as well. Okay. So because all these things that we're doing is necessary for us to prepare, all right, the ground in order for us to connect our worker node, all right, to the control plane. So let's go ahead and let's do the same thing for the, all right, for the control plane as well. So open this up, all right, and then edit inbound, okay, and we're just going to basically grab this. So copy that and then open up another UDP for that. But this time around, it is going to be, all right, the worker node, okay? And then the next one, which is this one, so copy that and then drop that, and that will be, all right, the worker node, all right, as well. Okay, so it's a two-way thing. It's not just a one-way, all right, stuff. So save all of that as well, and I think we're done. Right, so Selenium is configured, the port and the firewall, everything is configured, right? The control plane is also ready. So now we need to start adding nodes, right? Now if I say kubectl, all right, get node again, the only node that we have here is basically the control plane node. So we need our worker A and worker B, all right, to join these particular, all right, control plane. So let's see how to do that. Now, how do we join the node? Now, if you remember, when we did the kube ADM init, it actually generated a token for us, right? There was a token that we saw, and it gave us that instruction on how to, basically, join the worker nodes to the cluster and all of those kind of things. But of course, that is gone. So how do we get that back? So we can basically say kube ADM, all right, kube ADM, and then we can say token create. All right, and then we can say hyphen print, all right, hyphen join, hyphen command, right? Now, if you don't know this, how to get it, you can actually just use the help command, right? So, it's very handy. So just say help, and then if you scroll all the way up, you can see that right here. So you can see here, let's see, where is that? So here it says kube ADM join, right? So we can see that here, but then you can see the flag here, hyphen print command, and it says instead of printing only the token, it says print the full kube ADM join flag needed to join the cluster using the token, right? So that is basically what it is. So again, we can get that again. So we're gonna say, right? So I'm just gonna copy it from here. So copy that and then put that here. And then you press enter. Now that is going to generate the full command for you, right? So kubeadm join, all right, this is the IP address of the cluster of the control plane, and then 6443, that's the API, all right, port, and then there's the token right here, all right, that has been generated for us that the worker node will use to join, all right, the control, all right, the control plane. So we can copy this now. All right, just copy this whole thing, and now you can go to worker A. All right, so go to your worker A and just execute that right there. Is that okay? All right, so let's drop that here and let's see what happens with this. So enter. Oops, what did he say? Kubeadm token create. Oh my goodness, look at what we copied. Kubeadm token create, that was what we copied. Now, what we need to copy is actually kubeadm join. That is what we needed to copy, right? So that's why we saw that error. So let's go back. The thing we need to copy is actually this one, not this one. So we copied everything like this, right? That was what we did. So that was why we got that error. So let's copy from here and then we copy that, right? That's the correct thing to do. And then let's drop that here and then let's execute that, right? So it's still saying error. So what is the problem with that? Now, the reason why it's saying error is because the user is not running as root. Okay, so we need to run that command as the root user. Is that okay? So let's do that right away. Okay, so I'm going to say sudo all right, kubeadm join, and then you press enter. Now running pre-flight check, and then here it says this node has joined the cluster, right? Certificate signing request was sent to API server and a response was received. And it says kubelet was informed of the new secure connection details. Okay. So now, and it says kubelet get node on this control plane to see the node join cluster actually. Okay. So now this node has been added to the cluster. So if I go to my control plane here and I say kubectl get node, right, I can see my worker here, right here, all right, and then it's still saying what? Not ready. Okay, but then of course the most important thing here is that the worker A has been added, all right, to the control plane, but of course it's not ready because I mean some things will still happen behind the scene, right? So we can also do the same thing here. So let's copy the same command. So copy that and then go to the worker B and then drop that and execute the same thing. And then it's saying here that this node has joined the cluster, and it says certificate signing request was sent to the API server and a response was received. So if you come back here again and just run the same thing, we can see that worker B, all right, is saying not ready, but of course worker A is now what? Is now ready because the Selenium, all right, the daemon set has been configured and then everything is running as expected. All right, so worker B is also saying not ready, but of course, by the time you refresh it, it can still be saying not ready, but of course, by the time Selenium does its thing, it should also be in the ready state. Now, another thing that we can also do to basically check the Selenium, the configuration and all of that, and to basically test the what do you call it? To basically test the networking. I mean, the connection between all of the servers, the control plane, the worker nodes, to basically see that everything is fine. Is this, we can actually run this particular command here. So if you go to the command section, we can actually run this command, right? So we can come here, so just grab this, all right, copy that, all right, and then drop that here. And basically we need to have, all right, one of the Selenium ports, all right, to check this. So basically what I'm going to do is I'm going to say kubectl get port, all right, -n, and then I'll say kube, okay, -system, right? Now I need one of the Selenium ports as well, right? So I'm going to come here and just grab any of the Selenium ports, right? So I have about 3 of them. So this is 1, 2, 3. So I can grab this one, okay? Grab that one, drop that here, all right? And then I can copy this thing again, and then I can basically just, come here and drop it here. So I'll just do some edit real quick, right? So I don't need this one here. So I'm just going to remove this one. All right, and the one that I need actually is this one here. So this is the new port that we have. So copy that and drop that here. And of course, don't forget to delete this other one to avoid any kind of confusion. So remove that. Okay, and then now you can execute. So kubectl, kubesystem. So the namespace is kubesystem. So you are executing one of the Selenium ports, and then you want to see some kind of debugging, all right, and see the status, basically to check if there's a communication between the worker node and the control plane, right? So execute that. Now here it says cluster health, right? And it says 2 of 3 is reachable. And it says here kubectl worker A, all right, is still unreachable. Okay, so now this sometimes actually takes a little bit of time, right? So here it says okay, but until this one becomes 3 of 3 reachable, then you won't, all right, you will have to wait, all right, until everything is reachable. Okay, so we just have to wait a little bit, all right, for these to become reachable. I mean, we can keep checking using the same command, and now it is saying what? 1 over 3. All right, reachable. So here it's saying Kubernetes worker A and worker B, all right, these endpoints are not reachable. So this one is reachable, right? But this worker B says unknown. Okay, that is what you have here. So and it says 1 over 3 unreachable. So there's still some kind of networking, all right, going on behind the scenes. So we just have to wait a little bit, all right, for this thing to become, all right, reachable. Is that okay? So that is what we can do, all right, actually, here, basically, okay? So we can wait a little while, all right, and we just have to keep checking and check until everything becomes reachable. And then another thing that you can actually do is to go over to your security group. And you can just check your security group over again to be sure that everything that you need to configure actually has been configured all right correctly as expected. Right? You can refresh these to just check, if everything is where it should be. Okay, I mean, just to be sure that you don't have any kind of misconfiguration and things like that, right? So we need to just, check that basically. Okay, so we can just check all of these and then see that. So here we are on the control plane. So we can see that this is well configured. This is also well configured. All right, all these things are configured properly. I don't think we should have any issues with any of them. So let's check the worker nodes as well. All right, I mean, just to take notes, right? You never can tell. Some things may not be configured properly. So here we have the worker node and we have the control plane, worker nodes. All right, all these ones are opened up to everybody. All right, and then these ones are configured, all right, as they should be configured. Okay, so we can just keep checking that to be sure that everything is the way it should be. So 1/3. All right, so the endpoints now, both endpoints are now reachable, but the node is still saying what? Unreachable. So now, if I do kubectl get node, all right, so the two nodes are actually ready, but of course, until the cluster health is 3/3, then we may not, be able to deploy, all right, anything. Okay, so we have to wait until the cluster health says 3/3. So I'm just going to pause my screen here, and then once everything is steady and back, then I would, all right, continue, and then we just wrap it up, all right, here. Okay, so let's pause and let's wait and let's see what happens. Now, if you look at what you have here, we have 3/3 reachable. All right, that has now been all right configured. So 3/3 now it is what? It is reachable. I mean, now it means the cluster health is okay. All right, if it's a get node, all right, everything is basically ready. And of course, we can also check, all right, our ports. Okay, we can check our ports basically. You can say kubectl, all right, get ports. Okay, -a, all right, sorry, -a, capital A, all right, and then -o, right, -o, you can say Y, basically to just see, some more details about your ports, right? So you can see all the ports here, and then you can see all of the worker nodes, and of course you can see every bit of information right here. Okay, so you can see the ones that are on worker B. So you can see worker B you can see worker here, you can see worker A here, right? So the Selenium is actually running now, all right, on all of the worker nodes, okay? And everything is active and running. So if I do this again, I can see it says 3/3 reachable. Now, one thing that I did, all right, that I need to show you that actually caused that a bit of delay is that on the worker node SG side, now this ICMP that we configured, because if you look at the video from the beginning, we had 9 inbound rows, right? But then one was missing, and that was this ICMP. So what we did actually was to configure ICMP only for the control plane. So we didn't configure anyone for the worker node security group as well. I mean, it has to be a two-way thing, right? It's not just a one-way kind of traffic, okay? So we had to configure that. On the control plane, we also had to do, all right, almost the same thing, right? So we had to configure the ICMP, all right, as well on the control plane, all right, on the control plane security group. And now we can see that we have 3/3 reachable. And here we can see that all right, so here it says run kubectl run kubectl get nodes on the control plane to see if this node has joined the cluster. I mean, we've done that already, and we can see clearly that it has joined the cluster. And I mean, with this now, we can see it says 3/3 is reachable. So I mean, the cluster health is okay, and everything is actually all right, very, very fine. So now we can start deploying, all right, our pod. So now if I do kubectl, okay, and then I say run tests, okay, and then I can say the image that I want to run is, let's say, engine X, right? I can see that it says what pod has been created, right? So if you do kubectl, all right, get pod, all right. Of course, it's going to go to the default namespace. So the default namespace, you can see that the test pod is already running. And of course, you can expand that, okay, to just basically see. So we can say kubectl describe, okay, so describe pod, and then we can specify the name of the pod. So let's just say pod is test. I mean, we're dealing with the default, all right, so we're dealing with the default, namespace, right? So even if you don't specify a namespace, it's going to go to the default namespace automatically, right? So you can see that the node that these tests, pod was deployed on is actually worker A, right? So it was deployed on worker A. So that means if I do the same thing again, so if I say kubectl run test image nginx, right? So the name already exists, so it won't run that. So I can say test2 now, right? And then I will have two, all right, pods actually running. So test2 is running. So you can see it says container created. So it's trying to do creation and then it's trying to schedule. So test2 is actually running now. So I can come here and say kubectl describe pod test2, right? And I can see from here, let's look at it. All right, so the namespace also is default, and then the node is what? Is worker B. So the first test was deployed on worker A, the second one was deployed, all right, on worker B. And if you scroll all the way down, you can see it says successfully assigned default test2 to worker B, all right, and then container has been created, and then container, all right, has started. Right, so that is how to build a Kubernetes cluster from the very scratch. From this point on, you can begin to, all right, configure your ingress networking, configure your load balancer, all right, configure the service to expose your, all right, deployment or your ports and all of that. I mean, you've learned a whole lot, all right, in this session, okay? So thank you so much. If you have any question, please drop that in the comment and I'll be glad to answer all your questions, right? And of course, it doesn't end here. We're still going to be looking at other things as we go on together, all right, in this journey, all right, of, our Kubernetes learning journey together. All right, thank you so much. Once again, if you have any question, drop it in the comment and don't forget to subscribe, don't forget to like, and don't forget to share. Okay, so now before we go, we have to clear all our resources. I mean, we've spin up three small instances, and of course, those instances are outside of the feed tier. So I'm just going to close all of this, right? And I'm going to quickly go to my instances, all right, and do what you call termination. So I'm just going to terminate them immediately. I mean, I've done everything that I need to do. I don't need them anymore because if I stop it, I'm still going to be charged for the EBS volumes, all right, even though my instance is stopped. So I'm still going to pay for the EBS volume attached to them. And of course, you can clear out your security group as well, but I don't think you need to do that. You can leave that in case you want to, do something later on. You can still leave your security group like the way it is. You're not going to be charged, all right, for any of that. So thank you so much, guys, and then I'll see you, all right, on the next one. Thank you, and bye for now.